Now we're going to look at solving by graphing. To solve by graphing, you graph your lines and see where they cross. So my first line, I begin at -4 and move with M, so up 3, right 1. Then I graph my other line, begin with B, which is 3, move with M, which is down 1, right 2. So I can see that they cross at the point 2, 2. For my next line, I begin at 2 and then go down 2, right 1. And my second line, I begin at -2 and go down to right 1 as well. These are parallel lines, which means they never cross, so they have no solution. As I go to the right, my first equation only has one variable, which means it's going to be either a Hoy or a Vux equation. Since it's y equals, that means it's a Hoy equation. So we go on the y-axis to -1 and draw a horizontal line. Then we graph our second line. Begin at 4, and we go down 5 and to the right 2. So these lines are going to intersect at the point 2, -1. So that was our first way of solving equations. The next way was solving by substitution, and I want to use substitution when one of my variables is isolated. That means it's alone. So in the first example, I have y by itself. So I'm going to put parentheses around y in the other equation and copy it down. So -6x plus 4 parentheses and leave a nice space equals 4. And what I substitute in is what y was equal to, which is 3x plus 4. And now I solve a normal equation. So -6x, 4 times 3 is 12, so 12x, 4 times 4 is 16. Combine your like terms, so 6x plus 16 equals 4, 6x equals -12, and x equals -2. When I'm doing a system, though, I need to have two answers, so I'm going to substitute that -2 back in, and I use the first equation that already has y by itself. So y equals 3 times -2 plus 4, so y equals -6 plus 4, which is -2. So this point is going to be -2, -2. The next problem threw a lot of y'all off when we tested on it first, and I really call it, it's substitution, but I call it a set equal problem. If the left side of your equation is the same or equal, that means that the right sides are the same. So I can set these equal. -3y plus 1 equals 2y minus 9. And then we solve like normal. So I'm going to add 3y to both sides. So 1 equals 5y minus 9. So 10 equals 5y, and y equals 2. Now I substitute it into one of the equations. So I'll do the first one, x equals -3 times 2 plus 1. So -3 times 2 is -6, and -6 plus 1 is -5. So I get -5, 2. The next type of solution method we did was elimination. We want to do elimination when both variables are on the same side and they're nice and lined up. The first thing I want to do with elimination is look and see if one of my variables has the same coefficient. So I'm going to look at my x's real quick. Are those the same number? No. Look at your y's. They are the same. They're both 1. So that means all I need to do is change the signs in one equation. So I'm going to do the bottom one. Minus, minus, minus. So -3x minus 2x would be -5x equals -12 minus 8 is -20. So x equals 4. And now I'm going to plug that in. I always go to the equation that I didn't mess up. So in this one, that would be the first equation. -3 times 4 plus y equals negative 12. So negative 12 plus y equals negative 12. Add 12 to both sides, and y equals 0. So my point would be 4, 0. Going to the right, I notice neither the x's nor the y's have the same coefficient. So that's where we're going to switch and simplify, then you got to multiply. So I have 2 and 4, so I'll switch that to be 4 and 2. I see if I can simplify it all. I can. Those are both divisible by 2, so I get 2 and 1. So we've switched, we've simplified, and now we're going to multiply or distribute those to everything in my original equation. So my first equation is the only thing that's going to change, because when I multiply by 1, that doesn't change my life. So I get negative 4x plus 8y equals 8, and positive 4x minus 3y equals negative 18. I already have opposite signs with my x. I have negative 4x plus 4x, so those are going to cancel. Yay. I get 8y minus 3y, which is 5y, and 8 minus 18, which is negative 10. So divide by positive 5, sorry, and we get negative 2. My last step, though, is to plug it in. So I'm going to substitute it into the first equation. Negative 2x plus 4 times negative 2 equals 4. Negative 2x, 4 times negative 2 is negative 8 equals 4. So negative 2x equals 12. X equals negative 6. So my point is negative 6, negative 2. Last one. I notice once again that my x's don't have the same coefficient as each other, neither do the y's, so we're going to switch. Put 4 and 3. Notice I'm only putting positive numbers, because when we put the negative numbers, things start getting crazy. Alright, so we're just going to multiply by positive. Switch. There's nothing I can simplify, so now I'm going to multiply. So I get negative 12x minus 12y equals negative 48. Then 12x plus 6y equals 12. Now I already have it, so the x's are going to cancel. So I get negative 6y equals negative 36, which leaves me with y equals 6. Now I'm looking at my original equations. I kind of like the second one because it doesn't have all those negatives. So I'm going to plug into the second one. 4x plus 2 times 6 equals 4. So 4x plus 12 equals 4. 4x equals negative 8. So x equals negative 2. So my point is negative 2, positive 6. Don't forget that when we're doing systems, we could also get no solution and infinitely many solutions. So no solution means that my variables cancel and I get something silly like 4 equals 0. Infinitely many means that my variables cancel and I get something like 2 equals 2 or 0 equals 0, something that's always true. The next thing we looked at was word problems. So a lot of our translation words we're doing fine on. The main one, make sure you know quotient means division, and difference means minus, sum means add. But I want to focus on turnaround words. Turnaround words literally turn around the order. So those would be if I see something like less than, fewer than, subtracted from. Now, it doesn't really matter for addition, but it is technically true for more than. So subtracted from. With inequalities, you need to be careful with words like maximum, no, more than, and at most. those all mean less than or equal to. And then if I flip them, that means greater than or equal to. So instead of maximum, it would be minimum. Instead of no more than, it would be, whoops, that means than. It would be no less than. And instead of at most, it would be at least. Okay? So make sure you're careful with those inequalities because they're going to switch the order. So let's look at a couple of situations that sound pretty similar but are actually really different. So 2 is less than 5. That is telling me an inequality symbol when I have is attached to something like less than or more than. The next one says 2 less than 5. So in this situation, less than means minus because I don't have the is separating it. And now we're going to switch 5 minus 2. 2 is, then stop at 5, less than a number. So 2 is means equals, and then this less than means minus because it is separated from the is by the 5. And since less than is a turnaround word, we need to switch that. So it's going to be x minus 5, not 5 minus x. When we do systems of equations, these mean you have 2 variables and 2 equations. 2 variables, 2 equations. So let's look at the first one. A test has 20 questions worth 100 points. The test consists of true and false questions worth 3 points each and multiple choice questions worth 11 points each. How many multiple choice questions are on the test? So sometimes what I do is look at the actual question. So we're not going to solve it, but this can help me identify my 2 variables. So one thing I have is multiple choice questions. So multiple choice. Okay, and what's the other type of question I have? True, false. So I'm going to use M and T personally for my variables. So I like this kind of middle equation right here to start with. So true, false questions are 3. So 3 times my number of true, false questions plus 11 times my number of multiple choice questions equals, these are talking about points. So what was my total points? 100. And now I've used all of this information, so I can even scribble it out and look at what I have left. The test has 20 questions. Okay, so my other total is 20, and what do I need to add? I need to add my true, false plus my multiple choice to give me 20. The next one says 2 angles are complementary. What does complementary mean? Complementary means adds to 90 degrees. So they add to 90 degrees, and I'm just going to call them X and Y. You could call them A and B, M and N. No one cares. Just choose variables. I just need to make sure I'm consistent with that in the next equation. One angle is, so let's say X is means equals 81 degrees less than twice the other. So here less than is meaning a minus, which means it's a turnaround word. So 2y and 81, twice the other, and I need to subtract the 81. Lisa goes to the mall one day and buys 4 shirts and 3 pairs of pants for $85.50. She returns the next day and buys 3 shirts and 5 pairs of pants for $115. What is the price of each shirt and pair of pants? Shirt and pair of pants. So I'm going to use P and S for my 2 equations. These ones y'all are pretty good at because we kind of just read through the problem. So 4S and 3P equals my total of $85.50. And then I have 3S plus 5P equals 115. And I want to know, whoops, that's not 100. I want to know where she gets all this money. All right, and we would solve that guy by elimination. All right, last type. A company offers 2 plans for internet service. Plan A, you pay $200 for the modem and $30 per month for the service. Plan B, the modem is free and you pay $40 per month. After how many months will the cost be the same? So we could say things in a couple ways. We're talking about cost. So I'm going to say the cost of A is $200 for the modem, which I just buy one time, plus $30 per month. Versus the cost for the next one, the modem is free. It costs $0, and I pay $40 per month. Do you need the 0 there, really? Nope. Could I have used X and Y for this? Yep. Then we talked about a special system of equations where I have parallel and perpendicular lines. When I'm talking about parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. And you could write that out. I don't have my stylus, so I'm going to not write that out. And if I want to find slope from an equation, I need to make sure that I am solving for y. That means y is by itself. So in this first equation, the y is by itself. So I can just look and see my slope. So my slope would be 2. That means my parallel slope would be 2, and my perpendicular slope would be negative 1 over 2. The next one, y is by itself, so I can identify my original slope as negative 4 over 5, which would mean my parallel slope is also negative 4 over 5, and my perpendicular slope would be positive 5 over 4. But if I look at the third one, it hasn't been solved for y, so I need to get y by itself. The first thing I'm going to do is move my x term. So that gives me negative 3y equals negative 2x plus 12. Now I'm going to divide everything by what's in front of y, which is negative 3. So y equals 2/3 x minus 4. When I'm doing parallel perpendicular, I don't really care about that y-intercept, the last term. So this means my parallel slope is going to be 2/3, and my perpendicular slope to this line would be negative 3 over 2. So let's look at some writing equations. When we're writing equations, you want to remember about our favorite formula in the world, which isn't y equals mx plus b, it's y equals mx minus h plus k. And when I'm doing these, the first thing I need to do is find my original slope. My original slope is what we were just doing in the previous examples. I need y to be by itself, which it is, so my original slope is 4. I read the question and it says to find the parallel line, so my parallel slope would also be 4. And now I'm going to cross off all that information they gave me and use y equals mx minus h plus k, with my point they gave me being my h and my k. So y equals m is 4, x minus in this formula means change the sign, so the opposite of negative 2 is positive 2, and keep k as 5. Now we're going to distribute and combine like terms. 4 times x is 4x, 4 times 2 is 8, plus 5, not 15. So y equals 4x plus 13. Next we're going to do perpendicular to y equals negative 1/2 x plus 3. So perpendicular, I need to identify still my original slope, which is negative 1/2, and I want perpendicular slope. So I need to change the sign, make it positive, and flip the fraction, which is going to give me 2. Now that I have that, I don't need my original slope or my original equation. I'm going to plug in my new slope and my new point into our y equals mx minus h plus k. So y equals 2 times x minus means opposite, so positive 4, plus 6, keep k. Distribute and combine like terms. Y equals 2x plus 8 plus 6, so y equals 2x plus 14. The next one is different because it hasn't been solved for y yet. So the first thing I need to do is solve for y. So I'm going to minus 4x from both sides. So negative 8y equals negative 4x plus 24. divide by -8. So y equals 1/2 x minus 3. So let's identify my slope from that equation, 1/2. I'm going to reread my problem because you've already forgotten it by now, which is parallel. So my parallel slope is also 1/2. Cross it out, and there's my h and my k. So y equals m, which is 1/2. X minus means opposite, so plus 1, and keep k. OMG, it's going to be a fraction. That's okay. 1/2 x plus 1/2. And I'm just going to write this as a decimal. So 1/2 x plus 5.5. But you know me, I'm not going to give you one like that on the test. Okay, the last two have one variable. So if I start with one variable, I'm going to end with one variable. So parallel means it's going to be the same variable. So if I start with y, I end with y. And then what's my y value they give me? 7. Perpendicular means it's the other variable. So if I start with x, I'm going to end with y. And then I look at my point. It has an x and a y, and my y value is 9. The last thing that we've talked about this semester is adding and subtracting and then multiplying polynomials. Remember, these big things we've looked at, they're just called polynomials. And what we want to do if it's adding and subtracting in between is distribute and combine like terms. So what's really in front of my two parentheses? In front of this first parentheses, I have a 1. When I distribute a 1, it doesn't change anything. So I'm just going to drop it like it's hot. But in the second parentheses, I have a -1. And when I multiply by -1, it does change something. It changes my signs. So -1 times positive 5x is -5x. -1 times -2x squared is positive 2x squared. And -1 times positive 11 is -11. And now we need to combine like terms. So I have 5x squared can combine with positive 2x squared. So that gives me 5 plus 2 is 7. Then I have -6x minus 5x. So that would give me -11x. And then my last one is, we'll do blue, 9 and -11. So 9 minus 11 is -2. The next one, I have some cube stuff going on. Not going to change my life at all. So I have 1 in front, and when I multiply by 1, it doesn't change anything. So that means in both of these, I can just drop my parentheses. And I know someone's like, oh, but that's so much work. Right, but when it's subtraction, it does make a difference. So it's better to just do it all the time, and it always works. Okay, so 5x cubed minus 2x cubed would be 3x cubed. 6x squared plus 5x squared would be 11x squared. -7x plus 8x would be plus x. And 10 minus 7 would be 3. When I'm multiplying, that's when we're going to use the box. So this first one is a 2 by 2 box. So 3x plus 2, 4x minus 5. And now we're finding all the little areas in there. So this would be 12x squared, 8x, -15x. Whoa, that was so messy. And then -10. So combine like terms, and I would get 12x squared minus 7x minus 10. The last one is the same idea, I just have a bigger box. 2x minus 1, and then 3x squared minus 2x plus 4. So I get 6x cubed then -4x 3x squared, 8x, negative 3x squared, positive 2x, and negative 4. Alright, so I get 6x cubed minus 7x squared plus 10x minus 4.